from Anne Arundel Community College. This is our 9th year of water testing in Spa Creek. And we're planning something for next year for our 10th big 10th celebration. So we'll let you know as we figure it out ourselves. But we'd like to thank, it's done by originally it was done by all volunteers, and now we have Jason Burkholder, saying that right, who is works with Tammy, and then he goes around with Patrick Denker, who's one of our board members and a volunteer, and then Donna and Jim Jefferson, who test in the headwaters, the 2 headwaters areas. And so I'm sure there's other people that do it every once in a while. And I know there's people at Back Creek. I just I can't speak for them, but we're very grateful to our volunteers. We're grateful to the community college, to Tammy and Jason and Patrick and Donna and Jim for all the work that they've done for all these years. And anyone who's applied for grants knows that well, I don't know that everybody, of course, everybody doesn't do water testing. So, but in our grant applications over the last 9 years, we've always included our water testing as part of our application, because we wanted to have baseline numbers in the creek before it started after some of the restoration projects, but before later ones. And so we wanted baseline numbers so that maybe we could see, I know it's sketchy whether they have how much of an impact they have on water quality. I know that the jury is out on all those things, but we have to assume they're doing something, they're doing good. All the projects we've done are doing good. They haven't made the creek worse. They've helped with habitat restoration, with many things that are positive. And we believe that our water quality has been improved, or at least we're holding ground because of so many of the projects that we've put in to the creek watershed. So with that, I don't know, am I supposed to say anything else? No,
I don't think so.
Tammy Domanski, you're up.
Hello, everyone. I'm going to make sure I mute my phone, the things I've forgotten to do. So I want to thank Donna and Amy and all the Spa Creek Conservancy and a number of other organizations and individuals that I'll mostly do at the end when I have my slide with all the names on it. Today I'm going to go through some trends associated with Spa and Back Creek. As Amy mentioned, we have 9 years of data now. And I spent a lot of time over the last years having a lot of line graphs with a lot of individual sites along the creek. And as we get more and more data, that type of coverage would really happen if we have a very specific question about a site. Really, the only site that I'm showing much specifically about tonight is really just Hawkins Cove to look at long-term trends. So we're really looking at, the Spa Creek as a whole and starting to look at Back Creek as a whole. So I'll share my screen and get to the right years one. Here we go, except that didn't share. Let's see if that does it. All righty. All right, so can everyone see that?
Yep.
Okay, good. Woo. Okay. So as Amy and Donna mentioned, this work has been is going on 10 years next year of collecting a significant amount of data on Spa Creek, and now in the past couple of years on Back Creek also. We're very fortunate that we have the support from Spa Creek Conservancy to look at a number of really important parameters. So one thing that I mention every year is that when we talk about report cards, we talk about the state of the Spa Creek, but I kind of avoid the term report cards, because there's not a consistent list of parameters that each river or each water body uses. So we like to think in the big picture for what we know about Spa Creek and Back Creek. There's some things that other rivers focus on, things like submerged aquatic vegetation, because they have a lot of it, or at least some of it. We don't really have that. So I'm not going to dwell on what we don't have. We're going to dwell on what we can measure and improve on, and potentially get to the point where we might be able to do some seeding for things like SAV and other things. Okay, so let's see if I can make this go forward. So these are the sites on Spa Creek and Back Creek, and it's a busy map, I know that, but last year I realized I plunged into using all of the codes that we use for the sites, and about halfway in, somebody stopped me and asked a question like, what are all these site symbols for? So I realized just because I'm thinking about them every day doesn't mean everyone else just recognizes them. And in addition, as I've been thinking about these, and as we've been looking at multiple years of data, we can really kind of group parts of each stream or each creek for very common outcomes and common results, so that we can really look at more combined trends. So if we look at Spa Creek, there's the fresh non-tidal up at CG for Cherry Grove and SCM for the Children's Museum. You know, those sites, for some of the things where we look at the water quality, there are even different parameters and definitely different grading scales that are used. So on several of the graphs, or even the takeaways I talk about, I'll talk specifically about non-tidal versus tidal. Then when we move out some to headwaters here, midstream kind of merge, that's where you have, you know, in this area you have Truxton Cove over here, or Truxton Park, and then Hawkins Cove. Hawkins Cove was of particular interest when Amy and Mel and Donna brought me in to do the sampling because of the work that was being done and planned for that area. And so there's some commonalities for the challenges in that area also, this kind of spa headwaters. And then spa midstream, which takes all the way to the sites out at Eastport Yacht Club, where you're really looking at the mouth of and moving into, you know, very close to what you think about for parts of the Severn River. So you have, this is Cheston Cove over here, Acton Cove, Cheston Avenue over here, Old Sup. At someday we'll give up that name, but that's where the renovated marina is. I still think of it, that's where Capital Sup was once upon a time. The end of Shipwright here. And then we call this the mouth. It's kind of midstream, or sort of out there. We had moved out from Eagle Alley once upon a time, which for several good reasons, including access. And then when we look down at Back Creek, then we have BCC1, which is over here. It's near where the SPCA would be. And that's really the one main headwater site. One season we did some over on this kind of leg of that also, but we haven't done that in a while. And then we think about midstream. So we have here BCC3, which is right by Jabin's Marina and Ellen Moyer Park. And then BCC5 and BCC6, this is near, we have Jones Cove, and over here on the other side of Jones Cove, I can't remember the name of over there. And then this season, so the data I will talk about is, you know, last season and some trends from before that. This season, we're adding over here at Annapolis Maritime Museum and Park, East Porter Rockin is supporting some of that. And so we'll have something even closer to sort of the mouth of Back Creek. And so when I talk about these sites, you really will kind of see a trend in some cases of some of the data moving out from the headwaters in each case. So how do I assess the water quality? One common way that's been used in the past that I still like for several of the parameters is the grading scale that was set up, developed by the Mid-Atlantic Tributary Assessment Coalition, MTAC. This is the grading scale they use. You don't care about a lot of the detail of this, or if you do, we could talk about it separately. But for each one of the parameters that they have developed a scale for, they've given levels of health. Really good values get a 5, then 4, 3, 2, 1, down to 0, which is really bad quality. And then you take all of your sites and you do an averaging, mathematical weighted average, and then the value that you come up with gets applied to the scale. This was developed, through years of work by a number of people in the field that came up with these parameters. It works well. There's no such thing as a perfect scale. And it doesn't always apply perfectly to headwaters, and especially for some of the parameters to the non-tidal up Cherry Grove and Children's Museum on Spa Creek. But it's a reasonably good way to be able to have some quantitative and direct comparisons. We also use some recommended thresholds developed by EPA, things like some of the thresholds for total suspended solids and even for the Enterococcus bacteria, which aren't part of what MTAC has developed in general. Now, when I show some of the grades, things always look a little dire, right? If we look at these levels and they talk about, a C is a mix of good and poor levels of water quality. And when you get down to C- and D, it really makes it seem as though you would not expect to find any good health, that the water is just in very poor quality. So before, we start looking at grades that make us feel bad, right? Just last Friday, Spa Creek Conservancy was out with a group of individuals that was doing some environmental work and a tour on Spa Creek with Bates Middle School students. And one thing that was happening is 2 individuals from DNR were there, and they were doing seining, and we all stood around and were frankly just floored by how much diversity was in the seine right on the shore in one part near Amos Garrett Park. So not all of these were in the nets, but there are other things that people have reported. There was perch, there were mummichogs, menhaden, American eel, brine shrimp, croakers. And then when they went on the boat trip, they talked about seeing a sheep's head, and people have reported seeing rays. And this doesn't even include the birds and even the water snakes that were there to feed on the things that are in the water. So when we talk about water quality and it starts to feel like the water is just dead, it's really not, right? These are the water, the creek is, if anything, it's extremely resilient in the face of all of the challenges that it's facing. So now some data, because I do data, I have to present data. So one of the things that we focus on a lot, because we're concerned about our kids getting into the water, or when we go paddling or kayaking and going in exposure to the water, is bacterial levels. So we've been testing on Spa Creek, 9 years, and we started doing consistent sampling on Back Creek starting in 2020. And every week we take a sample of water, and we're testing specifically for Enterococcus. Enterococcus being the bacteria that are associated with the gut of warm-blooded animals and some waterfowl, geese, ducks, etc. The reason we're concerned with those particularly is because they shouldn't really be there naturally. So it's an indication that there is some pollution, some fecal contamination from some animal source. The Enterococcus itself isn't necessarily pathogenic, but it acts as an indicator. We take weekly samples, so if I showed that, that would be a huge amount of data. But because we do it consistently, the EPA has a cutoff, a threshold for a single sample. So if you pay attention, if you check every week, the single sample threshold that we use is the 104 bacteria per 100 ml sample. But if you look at continuing sampling, consistent sampling, you then do a geometric mean. And a geometric mean also helps to even things out a little bit, helps to take away some of the extremes. With living things, also, if you look at the data on a weekly basis, sometimes we have values of bacteria after a heavy rain or up in the non-tidal headwaters that are in the tens of thousands. So one value for a straight average can tank the entire season. So a geometric mean helps to dampen those extremes. So if we look over time, the good news is, definitely that as when we look at the tidal sites, so that's everything on Spa Creek from headwaters out, that we've seen an improvement in the geometric mean over time. And the geometric mean is consistently below the threshold that EPA sets, 35 CFU per 100 mil. That's by no means means that we don't have weeks when many of the sites are over the 104 single sampling threshold. There are patterns that we're definitely seeing when it rains, right? When we get more than about 0.3, maybe 0.4 inches of rain within 48 hours of sampling, a number of the sites are going to be over the threshold. But consistently, if we look at the trend, things look pretty good. I also want to mention that back here in 2016 and 2017, we did fewer sites, and we did have a higher proportion of what we would call more challenged sites. So part of this improvement is just the water might be getting better. Part of it is that as we've expanded the number of sites that we sample at, we have additional sites that are more midstream, right? When we think about bacteria, if they're coming in from with runoff after rain, sites closer to the shore are going to be more challenged by that. Once we were able to have Jason and Patrick go out on the boat, we now have more midstream sites, where you tend to see better quality data. When we look at SPA non-tidal, that's Cherry Grove and Children's Museum. Cherry Grove really is, completely fresh, non-tidal, but very challenged when it comes to bacteria. Overall, those two sites together, we see an improvement. Up by Cherry Grove, they did a lot of restoration work several years ago. There was some work done at Children's Museum, but we have a pretty good inkling that, this is greatly impacted by animal activity, maybe wild animal activity, but also even domestic pets that, if you have houses everywhere and people out and their dogs are even walking their dogs down by the creek, or if the wild animals make their way down to the creek, well, that's where they're then defecating. And if that's not getting cleaned up, especially pets, it makes its way into the water. This season, I think the number would have even been lower, but there was what they called a clog or a backup in sewer system in this sewer pipe late August, and we had an extremely high value at Children's Museum, and you'll see the effect on other values in a couple of slides also. And then when we look at Back Creek,
Tammy, can I say one thing? This is Amy.
Oh,
Since the restoration of the headwaters, there's been a lot more wildlife seen up there too. And probably at the Children's Museum, Debbie could probably tell you, but since those restoration projects were put in, the water quality is probably better from stormwater runoff, but there is a lot more wildlife sightings. So
yeah. But overall, it's still good. It's still good news because we see that it goes down. So this scale, just to make sure that that it could all fit and we could see values, this is even also a log scale. So if we look at this year, the geometric mean is less than half of what it was even last year. And then when we look at Back Creek in general looks pretty good. The headwaters site, BCC1, up by the up by the SPCA, that is often above the threshold. And this is something I think that's worth talking about. I don't have a good contact at the SPCA, and so I don't want to approach them and be like, hey, maybe you have some dog feces getting into the water up there. If anyone has a good contact, it might, I don't want to seem like we're at all accusing them. It's also a very kind of constrained area. There are other things that could be affecting it. But it's one thing to look into if there's something that we can suggest about the potential for runoff that's coming from that area that's contributing to the high bacterial counts there. There's a lot of concern this season. I've heard from several individuals along Back Creek. There's the water treatment plant there, the sewage treatment plant, and the odor is strong. And so a number of people asked me about that. We have not seen evidence of any actual leakage or any overflow there. The odor is an issue. I've talked several years ago, I talked to the people that manage that, but we have not seen evidence of actual sewage leak making its way into the creek. The closest sampling site to that would be the Jabins Ellen Moyer Park. There's a little stream that actually goes right across there. And when we've sampled there, when it rains, the values might be high, but we don't see any indication that there's anything coming from that treatment plant. Some other kind of interesting things that happened last season, and the clouds in that show when there was rain. Overall, last season, I'm going to show a table of that. We didn't have a huge amount of rain. It was a relatively, when you look at the entire season, it was relatively normal, but early season, we had very little rain. So there was a lot of comments that we saw this very quick jump up in salinity, and then it stayed high. You see here that we had this dip here. So it was going on kind of a typical trend. And then we did have a heavy rainfall, and then it dipped the salinity, and then it seemed like it made this very large jump. And then for a good point of the rest of the season, we didn't have a huge amount of rain. We did not have near the number of extreme rain events that we've had in the past. And so I wasn't all that, shocked by the salinity. And this was a trend that was observed along a lot of the Chesapeake Bay. The sampling we did along the Road River also showed that. It can affect the potential for higher salinity is actually good for things like oysters. It also then, the downside is the sea nettles come in earlier. But we've seen early this season, because we had a relatively wet spring, that salinities are back down where you'd expect them to be. Basically every year, salinity is significantly affected by the amount of rainfall we get. Okay, so then when we look here, another thing that we saw a somewhat unusual pattern last year. I don't usually make a big deal about temperature, because it usually is just going up. It's just going up. And this difference here is not as significant as it looks. Remember, the scale starts at 23. So it makes everything look there are huge differences. But when I first looked at the data from 2023, and this is just all of the temperatures averaged. I didn't do surface versus bottom versus mid. We just kind of looked at the whole slew of them, because we usually just see them going up. But it went down a little bit last year. And when I first looked at our data, I was convinced that we had totally messed something up, that our YSI was out of calibration, that there was a problem. But it turns out that also was a trend that was seen in the bay, in the watershed. It's slight. The overall effect is slight. Ours is probably a little artificial, the size of it, because of doing mid and bottom and things like that. But there was a slight decrease in temperature. I don't have a good reason for that. The Chesapeake Bay program, they've been talking about some potential reasons. We didn't have one thing that could potentially drop the temperature, things like a lot of rain. But something else that might be happening too is as we get rain, if the air temperature is going up and we have surfaces that are very warm, then it could potentially be warm water coming into the creeks also. I don't think this is a long-term trend. I think we will continue to see a very long-term trend of temperature going up, but that was one slight anomaly that we saw in a number of creeks and in the bay overall. Rain. So if we look at what we saw 2023 versus past years, the number of rain days affected by the number of sampling days affected by rain of at least 0.2 inches. Officially, when we're thinking about the effects, concerns about bacterial numbers being high, we talk about, half an inch or more. But we sometimes see, especially depending on the timing, some effects on other parameters, if there's even been even less rain than that, especially if it falls fast and hard, and within like 24 hours of sampling. Timing of rain is a big effector, and that we don't fully have a complete understanding of how it affects a number of these parameters. And what I mean by that is when the peak is, right? If you get slow, constant rain for a day, then by the time that builds up and you get runoff, you might not see an extreme peak. If you get 2 inches and it's just the right number of hours right before you go out and sample, you can see an extreme peak in everything, things like nutrients, and especially things like bacteria. Overall, though, if we look at the number of days, sampling dates, there were 18 sampling events. About a third of those were affected by some amount of rain. And if we look at the total rain, now this isn't total rain for the year. This is rain for our season, you know, mid-May-ish to the end of, near the end of September. Then that was pretty much more in line with like one of the first years that we sampled. Nothing like the extreme historic rain in 2018, which also then bled over into affecting 2019, some of the effects on the water, but less rain than we saw in 2022. And again, the timing of it. We've tended to see in years past that we've moved into this trend where we see a lot of rain early season. Last season, we didn't really see that. The beginning of the season was relatively low, a low amount of rain, which also, as I mentioned, contributed to, I think, the higher salinities that we observed. Okay, so water clarity. So water clarity is more complex than I ever realized. It's a measure of how the light penetrates, but it can be affected by things that are suspended or just the overall color of the water that can be affected by things like organic matter. So if we look at sampling here, you know, that deep color looks very much like dirt. So in this area, it looks like it probably is affected by suspended solids or suspended, particles, suspended solids. But in other areas, because of just organic matter, that's smaller, that's just particles that would flow past their filter. It wouldn't be collected when we look at weighing and actually quantifying the suspended solids. So if we look again, here, if we look at Spot Creek, the values, you know, had been going down, but there's something artificial here also. If we look at what happened in 2018, 2019, you might say, oh, that's great. Total suspended solids went down. Well, part of it is because we had just so much rain coming in that it got to the point where it just had washed everything out. And it was just extreme amounts of water. So it kind of diluted everything. If we look at the past several years, things have been relatively steady. If we look at Back Creek is higher than Spot Creek, and for the limited data set that we have for several years, seems to be increasing a little bit. The problem with total suspended solids is it can contribute then to sediment that basically can cover, if you're lucky enough to have like plants, materials, it can end up making the water less healthy. It can also block sunlight from making its way through. So it can adversely affect the water quality. The EPA recommended maximum is 15 milligrams per liter. And if we looked at the full season, the average across the creek and across Back Creek is always higher than 15. And it's a rare case where we even have a single measurement that is below that. The one exception is Cherry Grove. Cherry Grove, to look at it, is a nice, clear, babbling brook, and it usually has extremely low suspended solids. So something else that is has been an issue and is a continuing issue is chlorophyll levels and algal blooms. And so that material, which also can be part of suspended solids, or some of it will flow through, but definitely colors the water, is an ongoing challenge. So I use this picture. I have several pictures that people have sent with algal blooms, but I just really like the coloring on this. And it goes all the way back to 2009 from an article talking about the issues and the concerns with this. And it, as we know, it hasn't gone away. Already this season, early season, we feel that there's already a bloom going on in some areas. And some of that we've confirmed with some counts and some microscope work and some other things that we've done. But if we look at that, if we look at the chlorophyll levels, And this is where the MTAC grading scale comes in. For chlorophyll, you want lower levels. Yes, some chlorophyll is important to have that, shows that there's some algae, that there is photosynthetic activity going on there. But anything above, again, this is like 15 micrograms per liter, is where it starts to get unhealthy. So we have often an issue in our creeks with this Purocentrum minimum and a couple other species that really affect the clarity. And so if we look here, right after a bottoming out in 220, we have seen that for the grade, right? So this isn't concentration of chlorophyll, but if we look at the MTAC percentage grade, we had some improvements on Spa Creek, and then last year it went down again. Last year we didn't have what seemed like any really significant blooms. The year before, there was the early season one that lasted for a while. I'm sorry, year before last. Sorry, I'm thinking the season. Year before last in 2022, we didn't really seem to have an extreme bloom. Last year didn't seem bad either, but the chlorophyll levels suggest a little bit otherwise. And it's an ongoing problem on Back Creek also. So this is one of our biggest challenges. I mean, we have very poor grades for chlorophyll. We know what we should be doing, right? What contributes to algal blooms that we can have an effect on? Nutrients, right? So less fertilizer, less waste going into the water from even things like detergents, boat washing, but we have a lot of, marinas in the area. All of those things can contribute to, and waste. The bacterial waste also contributes significantly to nutrients that then stimulate these blooms. Temperature, they said last year there was this little decrease in temperature, but the ongoing long-term trend of increasing temperature also promotes the growth of algae. Problem is, you get the algae, and once it starts to die off, it's basically then sucking oxygen out of the water also. So ongoing problem, we kind of know what to do. It's just really hard to get that to happen on a large scale. So a related topic then, moving into a related topic, is dissolved oxygen. So when I look at the trend, and here we do have, this was a time factor, running out of time. We do have from 2022, 2021, and 2020, we have averages and data from Back Creek also, but it's not merged in with Spa Creek. But for 2023, I realized that when I look at the dissolved oxygen values, it's really very similar on Back Creek and Spa Creek. So instead of like splitting it all out, so you can basically look at the same thing over and over, I just put them together this year, and I will, before the 10th year next year, merge all of the data that we have so we can get an overall view. Dissolved oxygen though, the creeks look pretty good, right? So if we look at the MTAC score, right, and then we look here where I have that line, 65% for the score is a B grade. So for dissolved oxygen, the creeks look pretty good. Now we're also fortunate, right? When we look at bottom dissolved oxygen, our bottom might be at the deepest site at like MOS, the mouth, right, might be 3 meters. So everything is relatively shallow. So shallow waters tend to have fewer problems with this. Does not mean we don't have areas that are shallow and have problems with dissolved oxygen on a number of occasions. When we look at the coves where you have less mixing going on, Hawkins Cove near the bottom, we can have very low dissolved oxygen. Midstream merge, MSN, headwaters, those are pretty shallow, but they also can seem a little bit stagnant sometimes. So we can see low dissolved oxygen, but overall the shallowness helps overall with having a reasonably good dissolved oxygen grade. Now, okay, so I know this is a busy one. This is the one that I just wanted to, when we look at patterns, right? So we don't see anything really different on Spa Creek than we expect to see on the rivers. So if you look right early in the season, we have high dissolved oxygen values. You get to the warmer water holds less oxygen. We also tend to then end up with more algal blooms. So this is from last year, and we didn't have a huge number of algal blooms, but for algal blooms, you'll see this peak. Even though this isn't very high, you'll see this peak, and then it'll tank afterward because of the oxygen being drawn out of the water as the algae is being degraded. But, if we look at this, 5 is the key. Even though overall we talk about, the dissolved oxygen, we do relatively well on Back Creek and Spa Creek. 5 is the threshold for what we consider healthy for aquatic organisms. And in the middle of the summer, we still have a lot of values that are very low. And we see when you get down below 1 milligram per liter, it's considered anoxic and not able to really support any aquatic life. So we are not challenged with dissolved oxygen. We are just fortunate that we don't have even deeper water. So this is something else. All of these things are related, right? Temperature, warmer water, lower dissolved oxygen, more nutrients, more algae, lower dissolved oxygen. Okay. I wanted to show this. I know this is another loud one, but this is, I'm going to show bar graphs to show the trends for the nutrients. But I wanted to show this because last season, this really shows when I talked about like being able to break the creeks into areas. I tried 6 different ways to make this really pop out as the different areas. And I tried same color, but then I couldn't find the sites. So what you see is that if we look at things that are really near the headwaters, so if we look at like, Hawkins Cove, HW for headwaters, MSM, MSW, you see that they're going to tend to have more peaks. They're going to be more affected by things like runoff and things like that. When you get into like the midstream and out to the mouth, that's where you see the clustering mostly down here, right? Even if some of the nutrients make it into the water with runoff, it gets diluted relatively quickly. So then you see that, these are, relatively low. But when you really see the effect of weather and bad things happening, sometimes these patterns show a lot. So if we look on 6/29, we had a significant rain there. And so you see in the headwaters of Back Creek, you see this really extreme peak for nitrogen. So this also is one of those things that what's going on up there, I don't really think that there's nitrogen coming there somehow from fertilizer. Maybe animal activity, maybe feces, because to match that, if we look here, 8/24, and this huge peak of nitrogen at Children's Museum, that's also associated with the sewer issue. So this is also the date, this 8/24, where I have the very appropriate toilet there, where the bacterial count was like 19,700. So there's no doubt about the fact that that is definitely caused by the fecal matter that made its way into the water, which, blew out the bacterial count and nitrogen. So here with BCC1, that was a pretty good rain event. And again, it's timing because we had rain here on 7/27 that was close to within the time period for sampling, but it didn't seem to have that effect. Again, maybe we just missed that flush that time. But this is BCC1 is something I really want to spend some time thinking about what's going on at that site. If there's anything that can be done to alleviate some of the problems. Okay. So if we look then at trends over time, when we look at the grading scale, right? So I have a couple things broken up here. So the blue bars, the darker blue bars are the tidal sites on Spa Creek. And, we're seeing an increase over the last few years, right? We were feeling pretty happy in 2018, right? That, oh, look, we're seeing things go down. And then we had the historic rain, and now we see things kind of up and staying there. So yeah, this is a challenge that we have. This is a challenge that, you know, I think about it's like holding steady. These aren't, if you look at the number differences, they're not significant. If you look at all the way back from 2016, we started this, again, the differences aren't hugely significant, but they're there. So I think as Amy mentioned, there's a feeling that we're doing a lot to hold steady, but what can we do to be moving in the direction we'd like to be moving? And then when we look at the non-title, oh, I mislabeled that. The orange should be the spot non-title. Oh, no, sorry, I'm sorry, that's total phosphorus. So the TN is total nitrogen. The orange, I'm sorry, is phosphorus. And the scale is different somewhat for phosphorus, but again, we're still seeing that that creeping up. That is even somewhat more dramatic than we're seeing with nitrogen. And then if we look at Back Creek, last year was the first year we were able to do nutrient testing on Back Creek. And so we only have that one season's data point. But what it shows us is that Back Creek is pretty high up there also for both total nitrogen, which is in gray, and in gold, the total phosphorus. Back Creek has the challenge of like the most marinas, right? So many boats, so much area being used for marinas and boats and washing boats and everything, all the things that come from the hard surfaces on marinas. So it actually was oddly comforting to me that it wasn't worse for nutrients. And then when we look at the non-tidal, there we go, the non-tidal for Spa Creek, I have previous years of that also, but I had it broken down into individual sites. I need to put Cherry Grove and Children's Museum together. But those sites, if we look at the kind of lighter blue and green, the total nitrogen for the non-tidal was very high last year, but I think that is significantly affected by the sewer problem with that huge peak. We don't have as many data points. It's just 2 sites that are non-tidal, so that one really large peak can have a very significant effect. So I think that's part of the problem there. And we look at non-tidal with the phosphorus, it's not quite as bad. But I'm going to sound like a broken record, but this is where the challenges come, having these nutrients make it into the water compounds all of the other problems that we have. Again, with the resiliency, right, things could be a lot worse. And so in a lot of ways, we're holding our own. And there are things that we have seen that have worked. Hawkins Cove, we've seen some good progress, and I'm going to show a graph for that in a second. And other things where we've just been able to check on what's going on. When the marina renovations were being done, right, we have several sites right along the water in front of the both marinas, I guess, Annapolis Yacht Club, and I always forget the name of the marina that Capital Sup used to be at. But during that entire construction, we saw very little difference. We didn't see huge increases in total suspended solids. We didn't see huge increases in nutrients, which at least allowed us to be able to track and make sure that they were using the appropriate controls to prevent things from getting into the harmful things getting into the water due to construction.
Tammy, that's SAYC.
Thank you. Thank you. This is extremely data heavy, but it's the only thing I wanted to show here was trends, because Hawkins Cove, not cover, which of course I knew I was going to find the typos as soon as I put it out there. Hawkins Cove trends. So we have so much data, and so I can show you average numbers, and I can show you slide after slide, but I kind of just like the visual look of this, other than the fact that it looks like an EKG. But if we look here in the greenish blue toward the top, that's chlorophyll, and these aren't grades. This is the chlorophyll concentration. So if you look at the dotted lines in each case, it's showing the long-term trend. So we know that so many things affect what's going on, right? Whether it's a new construction site, or we have a really rainy season, or we have a very dry season. Wind, we know, because how it affects the tide can throw things off. Sewer overflows. But if we look long-term from 2016 to 2023, we see the long-term trend is a slight decrease in chlorophyll. Well, that's good news, right? We see the long-term trend for total suspended solids is going down. Well, that's good news, right? For dissolved oxygen, we want higher concentrations. And so if we look, and this is also on a log scale. So it would look even a little bit more impressive if I had it on a linear scale and each one of these separate. But I wanted to put them on the same graph. If we look, there's a slight increase over time in the overall dissolved oxygen in Hawkins Cove. Well, that's good news. And total nitrogen and total phosphorus. Total nitrogen also has an overall decrease. Total phosphorus seems rock steady and hasn't moving. And I would say that's not great news, but it's the one thing that made me even more confident in the other trends. If every single thing would have looked like, oh, it's going down a little bit or up a little bit, I would have maybe started to think that the data was just saying what I wanted it to say. But total phosphorus seems over a time has just not changing in any significant way. But there are things that we can say that we're making some progress on. And I have not yet done this type of analysis with every one of the sites, but I've kind of decided this is the next thing I'm going to do for my own knowledge to really look at these long-term trends, which I think are really what we want to be looking at. No 1 or 2 years is ever going to give us data to really see what's happening in any long-term way. So with that, all right, I think I wasn't too long. I'm going to do that. I want to thank all the volunteers and all the people that helped. Patrick Denker, Donna and Jim, Amy and Dan, the Denker Foundation, which last year helped support the nutrient testing on Back Creek, the Eastport Yacht Club Environmental Committee, which has supported work over the last handful of years, Eastport Rockin, which is supporting the new site at Annapolis Maritime Museum this season. Greg Malley for putting together the app that we use to collect data in the field. Jason Burkholder, who's been working on this project with me since it started. Live Water and CAPSUP, which have provided funding for bacterial testing and some of the physical parameter and nutrient testing also. If you have questions after we're done that you didn't want to bring up here, my email is at the bottom of the screen, and the websites where a lot of this information is posted, more detail, all of the data. Some people are like, it's too much data, and other people are like, oh, I want to see more numbers. All of these data, all of the numbers that went into all of the analysis, all of it is at one of the links at that Google site. And with that, I'll finish up, and if anyone has any questions.
Thanks, Tammy. That was great. It makes me so happy to see that Hawkins Cove is even just a little bit better.
Yeah.
That's a good trend. And I wanted to say that we are, the Conservancy is working, we're just in the design phase of Upland Truxton Cove. And, hopefully some construction projects will go into the ground, maybe 2025, not sure, it might not be till 2026, but it'll be really nice to have all these numbers from all these years up in that, the top of the, the headwaters, so that we'll be able to see if there's any impact from the construction projects, because there is a stream that goes through the neighborhoods of Saltaire, the Landings, and North Green. That stream goes right into Truxton Cove. So.
And what are those construction projects exactly? I know they Phragmites that they will be spraying and they've knocked it down, but what are the construction projects?
There are none yet. We have nothing to do with that Phragmites spraying. I think that's the city, like Rec and Parks, I think, got some funding to do that. So ours will be upland projects in North Green and the Landings, which are right across from the Salvation Army off of Hilltop Road. And so they are so we always go upland first before we do any of the in-stream projects. So those construction projects will be, one is going to be, it's a parking lot now. It was a tennis court at North Green. It's going to be turned into a submerged gravel wetland. And that sits right on the stream there. There's a couple of other places that will be collecting, in North Green in the landings that will be, that have a lot of runoff going to them now off of parking lots or the street or something like that. Those will be, constructed. There'll be rain gardens or, some kind of, BMP there. And then in the in-stream work which will be working in the stream that goes through Saltaire and then goes under Hilltop Road over to Truxton. That is the next phase of this. But this has been a multi-phased kind of project. So we have no funding for construction. We're just in the design and permitting stage right now. Anybody else have any questions for Tammy? Tammy, thank you so much. That's so much data. It's very interesting to see how it all washes out there.
There was one in the chat
Thank you.
about the about the jellies. And at the beginning, I mentioned salinity, and the salinity was high last season, and it got high it was higher than normal and got high early in the season. And we think that's due to the low amount of rain early in the season, and that's what the jellies like. They like the higher salt. So other than that, that was it. Thank you, everybody.
Thank you.
Bye, everyone. Thank you so much.
Okay, we think about everyone.
Thank you.
Thank you.
Thank you.